Good morning to everyone. Today we are going to present the topic on multiplayer soccer and wireless embedded system presented by myself Bharat Kumar and T. Gauri Shankar and N. Ajit. Okay. Introduction. What is embedded system? An embedded system is a computer system with a dedicated function with a larger mechanical or electrical system, often with real-time computing constraints. It is embedded as part of complete device, often including hardware and mechanical parts. Embedded system control many devices in common use today. Okay, wireless connected embedded systems are increasingly common in today consumer electronics, ranging from wireless keyboards, mouse to music player to running shoes. This device often involves a simple point-to-point connection, often between a simple sensing device, example mouse, and a base station that is attached to more capable computing device, example PC. On a horizon, there are even more products on the way that will extend this model to multi-point connections. This includes home automation systems built around new ZigBee standards as well as various applications of multi-hop sensor networks. Okay, next slide. Course content and goals. Intuitive microcontroller, detailed timing of input-output operation, basic of device drivers and interface techniques. Design their own USB device from the basic ICs wired together on a breadboard. They connect some simple sensors to a microcontroller and write the interfacing firmware. They do not have any runtime support. They must access the microcontroller configuration. Registers directly use the timers to schedule their sensor readings and communications. They use a USB interface chip to create a connection between the microcontroller and a PC. Then write a simple USB device driver for PC so that the application can communicate with microcontroller and sensor. Next, hardware software platform. The platform we use on basic on Intel iMoto 2. The iMoto 2 was designed as a high capable wireless sensor network mode. It consists of PXA 271 processor running at adjustable speed from 13 to 461 MHz. It uses embedded Linux for its runtime support and comes with 64 MB of memory, half RAM and half flash with the same package as the processor. In addition, the baseboard includes an 102.504 radio based on a Chipcon 2420 for a bandwidth of up to 250 kilobit per second in a 2.4 gigabits in unregulated band, and designed the game. Although we decided on the idea of multiplayer video game before the course began, the precise details of the games are followed below. Data packets were developed as the course progressed. We decided on utilizing controller that could move a player into 2 dimensions. Soccer quickly emerged as a game that could be wired to accommodate our requirement for the project. It should involve every student simultaneously and required only 2-dimensional control for each player. Lessons learned and next step. This was an ambitious exercise as we developed an entirely new project along with updating the hardware and software platform used in the course. Due to time constraint, we are forced to leave the detailed design discussion for the project unbound when the course started. This turned out to be an excellent approach as it led to much deeper student learning. We are able to collectively design the game through initial brainstorming experiments and data collecting through a lab assignments, and then further refinement or group leading to highly engaging final demonstration. A 30-minute soccer match between the 2 sections of the class, Tuesday and Wednesday on the final day of the course. The match was held in our building auditorium or a large projection screen during the lunch hour to guarantee a large audience and increase awareness for our efforts within our department. Acknowledgements. Our thanks to students of Winter 2007 edition of CSE 466 Software for Embedded System for the passion, preservation and enthusiasm in helping us develop a new approach to teaching the course and for fantastically fun final soccer match. Special thanks to Intel Corporation and its university relationship program for generously providing the wireless platform iMoto 2S and the sensor boards we are used for this course, as well as their consistent support of our educational mission. We would also like to thank Roy Want and his team and IntelSage for providing an excellent starting point for 802.15.4 protocols we used. Futures. The top on the left has a PXA 271 and a memory in the large chip at the top center. The bottom on the right has 202.1.4 Chipcon 2420 radio within the square in the center. The long connectors on both sides connect to the other board 2 ports. The top and bottom of the Intel iMoto 2 basic sensor board. The 3D accelerometer sensor is just below the yellow dot on the right. The top and bottom of the iMoto 2 Super board containing LCD microphone speaker, joy dial, USB connector and a heart rate sensor. The 3 boards sit attached together with their rechargeable battery. The side view insists on the left shoe. The other 2 boards and this below larger board in larger pictures. Thank you. Have any queries? Contact me. Thank you.